So for most of my audience is, I believe, not used to the lingo, not used to the vocabulary, has never maybe read about this analog missions for Mars. So can you tell us a bit about what an analog mission consists of? What are you doing? How big the crew is? What are you trying to discover and explore while you're on the mission? What you're trying to test?
Yeah, so what do I mean when I talk about a Mars analog research station or a Mars analog mission? Well, an analog is a counterpart to something. We talk about an analog clock, for example. So that is a clock with hands on its face that tells us the time. It's a representation of the passing of time without actually being time itself. So an analog station is a simulated Mars station that ideally looks something like the sort of Mars base, Mars station that we would live on when people go to Mars. It's about the same shape, it's about the same size. You have the same amount of people in there, and you can use it to explore the questions that we need to answer for going to Mars. Like, how big does the station have to be? Is it better to have people living over 2 or 3 decks or over one? So you can imagine living, is it better to live in something like a lighthouse that's tall and thin, or something that's more like an airliner that's low and long?
Mm-hmm.
We can address things like how many people do you send? Can we send 4 people, or is it better to have 6? Or should we go for an odd number of people, like 5 or 7? What sort of skills do they need to have? Uh, that's something else we can look at. How long can you spend each day working outside? Can you go outside every day, or is that just too much hard work? Because remember, when you're in a Mars analog station, you don't just open the door and walk outside. You put up a mock-up spacesuit, which is a costume, but it's a realistic costume because there's a big bubble helmet, and it's got fans that pump air through the helmet so you don't suffocate. You've got a water supply. You have a radio to talk to each other and back to base, and it's very heavy. The one we wore in Utah last time I was there weighed 17 kilos. So imagine, walking with a 17-kilo backpack on your back. It's what you do on a hiking trip. But you don't just walk in it, you work. So imagine wearing a big backpack, 17 kilos, and then changing the tire of your car or doing some gardening. So that is what it's like to go on a simulated spacewalk or Mars walk from a Mars analog station. It's hard work, it's tiring, and it may turn out that we can't do it every day. We might be able to do it only once every 2 or 3 days. These are the sort of questions we look at. So that's a Mars analog station. I've been on about 6 expeditions so far, ranging in from a couple of weeks to 3 months, nearly 3 months. And they're great fun. They're hard work, and we've learned a lot from them.
Which was the
The other
most
kind of thing is sort of a Mars analog expedition. So
okay?
these are sort of things that you do to um, places that in some way resemble Mars. Now, what does that mean? Mars is its own planet, and if we could find places on Earth that were really like Mars, there wouldn't be much point going to Mars. But these are places that in some way have some aspect that can teach us about Mars, whether it's to study their processes as a geologist, to look for odd forms of life that might be living there, or simply because it's the kind of environment we can test our tools, our robots, our drill rigs. And these sort of Mars analog expeditions we can do in many parts of the world. You can come to Australia. We do them in Central Australia. You could go to Ladakh in northwest India, this cold, high altitude desert I mentioned earlier. We could go to the Arctic, to Devon Island, or we could go to the Antarctic. And people do this. They take their equipment, they take their tools, they study these environments, and also they study how their tools work. Is it better to have a drill rig that works in one particular way, as a particular side, or is it better to have a different design? And we can test all these questions much more easily than we can on Mars. Because if we send them to Mars without testing them, something's bound to go wrong.
As I'm sure they have gone on missions as well. As I'm
Oh
sure
yes. So, for
things have gone.
example, at the moment on Mars there is a lander called Insight,
Mhm.
and this is a geophysical observatory that's landed on Mars last year, I think it was, late last year. And the idea was it would study Martian earthquakes. It would measure the amount of heat that's flowing out of the ground. You know, Mars' core is hot like our core, and heat gradually leaks out. And they wanted to measure how much was getting out, because that tells us what the inside of Mars is like. It was also going to measure the weather station. Well, the weather station is working fine. The seismometer measuring earthquakes is working fine, but the heat flow probe has been really embarrassing. So they had a tool called a mole, which was like a rod that pushed itself down into the ground. And they tested on Earth, and it worked fine. They set it up on Mars, and well, first of all, it started going in, and then it started going sideways. So they stopped and did experiments and started up again and went a bit further, and then it started coming back out of the hole, which was really bad. So at the moment, it's still sitting there more than halfway out of the hole, and the crew are trying to work out, the crew on Earth are trying to work out how to save this project if they can.